Hi everyone, welcome to Homeschooling SAT Prep channel. Today in this video we are taking part 2 of the probability chapter. In part 1 we have already covered basics of probability, coin and complement probability problems, then dice and card probability problems, and at the end I gave you 3 practice problems to solve by yourself. I hope you have solved these practice problems. If you haven't watched part 1, I'd request you to go to the YouTube playlist section and watch part 1 first, clear your basics, then come to part 2. You can find the link at the top of I button. In part 2, we will take some geometric probability problems. After that, we will take some conditional probability problems. Then we will take some dependent and independent event probability problems based on multiplication rule of probability. Especially last 4 questions are very important. A lot of students were unable to score full marks because of those 4 tough probability problems. So stick till the end of this video. And after solving all the problems, I'll give you 3 practice problems at the end of this video, which you have to solve by yourself and comment your answer in the comment section below. If you want to seriously prepare for SAT exam, you can check out our various courses on Homeschooling SAT app and website, starting from a very affordable price. All the links are provided in the description below. Now let's move on to the questions now. First, we will take geometric probability problems. If you have read geometry, in which you have read areas chapter, then you can easily solve these geometric probability problem. So let's start with question number 1. The question number 1 says that a missing helicopter is reported to have crashed somewhere in the rectangular region shown in the figure. What is the probability the, that it has crashed inside the lake shown in the figure? So as we know that helicopter can crash anywhere in this region. So what we're gonna say that area of entire region, area of entire region. So let's find out. So it's a rectangle. So area of a rectangle is length into breadth. So 4.5 into 9 kilometer. So 4.5 into 9. So that is going to be 40.5 kilometer square. So this is the area of whole region. And we have a small lake here. We have a lake here in this entire region. We have a lake here. So as we can see, the breadth of this rectangle is 9 and this is 6. So the breadth of this lake would be how much? 3 kilometers. Similarly, the length, as we can see, the whole thing is 4.5 and this is 2 kilometer. So the breadth would be 2.5 kilometers. So from this, we can find the area of lake, that is equal to 3 kilometers into 2.5 kilometers. So this is going to be 3 into 2, 6, and in 0.5, that would be 1.5. So 6 plus 1.5, 7.5. And we have to find the probability of helicopter crashed in lake. So this would be area of the area of lake, that is the favorable outcome. That is area of lake divided by total number of possible outcomes. So the helicopter can fall anywhere in this entire region. So area of entire region, area of entire region. This is lake. So 7.5 divided by 40.5. So we can move this and this. So this is 75 divided by 405. Let me put it on my calculator to further factorize it. So this is going to be 5 divided by 27. So let's see option B. As we can see, 7.5 divided by 40.5 can be written as 75 divided by 405. So option B is your correct answer. This is your answer. Option B is a correct answer. Now let's move on to the question number 2. In the figure below, 2 is the radius of the circle P. So this is the circle P, this is the radius. So 2 and this is also radius, so 2. So the diameter would be how much? 4 of circle P. 4 is the radius of circle Q. So if this is the radius, so from here to here it is 4. So then this is also the radius, QB is also the radius. So this is going to be also 4. And the whole diameter would be 4 plus 4, that is 8. And AB is the largest circle. So this is the largest circle AB. If the dart is thrown at the circular target and is equally likely to hit any point on the target, what is the probability that dart will hit the shaded region? So that should hit this shaded region or this shaded region. So how are we going to find it? First, what we're going to do here is we can say that AB is the diameter of the largest circle. So largest circle AB, largest circle diameter AB is equal to, so 2 plus 2, 4, and 8, 4 plus 4, 8. So 8 plus 4, 8 plus 4 is equal to 12. So we can say that the radius of circle AB will be, because radius is half of the diameter. So half of the diameter AB is, so AB divided by 2. So 12 divided by 2, this is going to be 6. So now we know the radius of this largest circle, that is 6. Now we have to find probability of dart hit shaded region. So we want favorable outcome, so that is the shaded region. So shaded region area divided by area of largest circle AB. So this is our total number of possible outcomes. So this is the favorable outcome where the dart should hit. So shaded region. So how are we going to find shaded region is? Shaded region is equal to area of largest square. So as we know, area is pi r square. So the largest circle area minus both small circles area. So what is going to be? So pi r square. So the largest circle radius is how much? 6. So pi r square. So pi would be written, and r square. So radius is 6 for the largest circle. So r square would be 6 into 6, that is 36. So 36 pi minus area of these two circles. So pi, the radius is 2. So 4 pi. So 2 into 2, 4 pi. And then this smaller circle. So pi r square, so 4 into 4, that is 16. As because the formula of area of circle is pi r square, so 16. So this is going to be 36 pi minus 4 plus 16, that is 20 pi. So the shaded region is 16 pi. So the probability of dart hitting the shaded region is 16 pi, and divided by the area of the largest circle. So largest circle area is 36 pi. 36 pi. Pi got cancelled. Then we'll 5 4 times 4 into 4, 16, and 9 times. So the probability would be 4 divided by 9. So option A is your correct answer. Now let's move on to the next type of problem, that is conditional probability. In these types of problem, you are given a condition and you have to find probability keeping that condition in mind. Now let's take some question here. In question number 3, it says that if one of the seniors from the sample is selected at random. So as we can see, we have a table here. The table above list ensures of a survey of a random sample of 250 high school senior and freshmen. Each student selected one subject that was his or her favorite. So the question says that if one of the seniors from the sample is selected at the random. So instead, seniors. This is very important. This is the condition. We don't have to select from the total students. The condition is that we have to select one of the students from the seniors. From the sample is selected, if one of the seniors from the sample is selected at random, which of the following is closest to the probability that the students selected science as his or her favorite high school subject? So the question number one, we have to find the probability of the senior probability of senior science student. So as we know, we have probability is favorable by total number of possible outcomes. So what is going to be our possible outcome? Total number of possible that is because here the sample size is from senior. So total number of seniors. That because it is said that we have to choose senior science students from all the senior students. So total number of senior student divided by senior, sorry, on numerator it would be senior science student. So as we can see here, senior science students are how many? Senior science students are 38 and total number of senior students are 120. So what we're going to do here is total number of possible outcome, that is total number of senior students, that is 120, and the favorable outcome that we have to find is senior science students. So senior science students are 38. So if we divide it, so 0.316, or it can be almost equal to, because in the question closest to the probability, so 0.32 can be written. Now let's take second part of the question. Among all the high students, what is the probability of freshman? What is the probability a math freshman can be selected? So probability of math freshman. But here we are not given any condition that it need to be selected either from freshman or senior. So what we're gonna do here is instead of we'll have total number of students, because it is not mentioned in the question that are they going to be selected from senior freshman or senior or freshman. So we'll take all the students, total number of students in high school, and in the numerator we have math freshman. So there is no condition probability in part 2 of this question. Part 1 has a condition that it should be selected from seniors only. So what is going to be answer? So math freshmen are how many? Math freshmen are 30 and the total number of students are 250. So 30 divided by 250, that is going to be 0.12. So option C is your correct answer. Now let's move on to the next question. Question number 4 says that the table below summarizes the result of 200 law graduate who has passed the bar exam. So this is the condition given, who has passed the bar exam. So we will eliminate who did not pass the bar exam. We will use only this table only, because in the question they said that who passed the bar exam is chosen at random for an interview. What is the probability that the person chosen did not take the review course? So probability of student passed student did not take review course. So because we are considering only the student who has passed the bar exam, so we will not take them. So so this one would be students did not take review course divided by total number of passed total number of students passed bar exam. So as you can see, the total number of students who has passed the bar exam is 18 plus 7. That is our sample size, or the total number of possible outcome, that is 18 plus 7. And we have to find the probability that did not take the review course. So 7 did not take the review course. So we can say 7 divided by 25. So option B is your correct answer. Now let's move on to the next question. Question number 5 says that if the table below if the below table students with various pets provided, what is the probability that student has a cat? So first, probability of getting a cat. So student has a cat divided by total number of students. That is going to be a total number of possible, and this is a favorable outcome. So what we're going to do here is, so total number of students are 3 plus 14 plus 5 plus 11. So what is going to be 3 plus 14 is 17. 17 plus 11 is 28, and 28 plus 5 is 33. So total number of students is 33, and student has a cat. So the student has a cat is 3 plus 5. So this is going to be 8 divided by 33. In part 2, we have to find probability of student has a cat given they have a dog. Given they they have a dog. So our total number of possible outcome would be, because in the student has a cat should also have a dog. So we can, this is our total number of possible outcome, 3 and 14, because the condition is given that they should have a dog. So the students has a dog is 3 plus 14. So that would be 17. And among these 17, who has a cat? Only 3 of them has a cat. So 3 divided by 17 is going to be your answer. In third part of the question, student who has a cat also has a dog. So P, probability of student has a cat also has a dog. Has a cat also has a dog. So our sample space would be from has a cat. So we will take this as a total number of possible outcome. So this is going to be student has a cat. Student has a cat also has a dog. So what we can see, student has a cat is 3 plus 5. 3 and 5 has a cat. So total are 8. And among these 8, only 3 of them has a cat and has a dog. So the intersection point is here. So only 3 out of 8 has. So the probability would be 3 divided by 8. So let me see what is going. So option D is your correct answer. Multiplication rule of probability. We use multiplication rule when we have two events happening at the same time or one after another. And those two events can be either independent of each other or they can be dependent on each other. So let me take independent event. So let's take the example. In, in a deck of 52 cards, what is the probability of selecting a king and a queen from the deck with replacement? So how we can find an event is an independent event? If things are replaced back, then it is an independent event. Let me teach you what I'm trying to say here is, we have a deck of cards. Total number of cards in this deck is 52. In the question, it says that first we have to find the probability of selecting a king and a queen. Then after that, we have to find the probability of queen in that order from the deck with replacement. So what he's trying to say is, this is a king here. First, we will take find the probability of getting a king. We'll take one card out. So now what we're gonna do here, after finding the probability of king, we will left with 51 cards only. But here the question is given with replacement. So whatever the king you have taken out in the while finding the probability of king first, you put that card back again. So when you put that card back again with replacement, then the total number of cards will still remain 52. So when the next time when we will find the probability of queen, so the total number of cards will be still 52. So we can say that we can say that the second event, that is finding the probability of queen, is not affected by the first event, that is finding the probability of a king. So let's read what is an independent event. When two events does not affect each other, because in in the first part we took a king out, then we place it back again in the deck. So the total number of cards will remain unchanged. So that's why it is an independent event, because finding the probability of king is not affecting the to find the probability of queen. So let me take this example. In a deck of 52 cards, what is the probability of selecting a king and a queen in that order? So first we are selecting a king in that order from the deck with replacement. So with replacement, first we will find the probability of finding a king. So total number of cards were 52, and we have 4 kings in a deck of cards. So 4. So we have taken this card out. Now in the question it is given with replacement. So now we will put that card back again in the deck. So now we will have how many? 52 cards again, because we have taken that card out and we have placed that card back again in the deck. So still we will have total number of cards would be 52, and we have to find the probability of finding a queen. So whenever and is given, we use multiplication sign, and whenever or is given, we use addition. You will understand this concept further when we will solve the question. So when the possible outcome, total number of possible outcome does not change, or the total number of card in the deck does not change, so it show that both the events does not affect each other. Now inverse of that, if we took out a king card and we kept it out, so now what we now the total number of cards are how many? 51. And then we find the probability of queen, then we are finding the probability of queen without replacement. So what we are doing here is first we are taking a king card out. Now we are left with 51, and from that 51 we have to find the probability of queens. So let's take this example. A dependent event, when second event is affected by the first event, because we have drawn a king out. So because of that first event, we have only 51 cards left in the deck. So this is the example. In a deck of 52 cards, what is the probability of selecting a king and a queen in that order? First you will select a king, then and a queen in that order from the deck without replacement. So whenever independent event is given in the question, it will be provided with replacement. And for dependent event, it would be provided in the question without replacement. And if nothing is mentioned in the question with or without replacement, we will by default we will take without replacement. So the example says that in a deck of 52 cards, what is the probability of selecting a king first? So first we'll select a king. So total number of cards are 52, and the total number of king cards in a deck is 4. Now that card is taken out. Now we are left with 51 cards, because the card has not been replaced, and because card has not been replaced, the first event is affecting the outcome of second event, because now the total number of cards are only 51, and from those 51 cards, the probability of getting a queen is, we have 4 queen cards, so 4 divided by 51. So answer would be 4 divided by 663. So this is the concept of multiplication of probability of independent event and dependent event. How you can find that the event is an independent event? If it is given in the question that with replacement is given, and if in the question without replacement is given, it is a dependent event. And if nothing is mentioned with or without, so by default we'll keep it as a dependent event without replacement. Now let's move on to the questions now. Question number 6 says that the 3 cards shown below are taken from a box of 10 cards, each with a different integer on it from 1 to 10. What is the probability that the next two cards selected from the box both will both have even integers on it. So let's name all the cards: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 cards here, and we have taken out these cards 3, 5, and 9. So we have taken out these cards. Now, how many cards are left? So remaining cards left is equal to 1, 2, 4, 6, 7, 8, and 10. So 1, 2, 3, 4, 5, 6, 7. So total 7 cards are remaining. And in the question, we have to find the next two cards selected should be an even integer. So how many even integers are there in these remaining 7 cards? So remaining even cards. So 2 is an even number, 2, 4 is an even number, 6 is an even number, 8 is an even number, and 10 is an even number. So we have total 5 even cards remaining. So now we have to find the probability of, first we will pick an even card and an other even card. So as we have read in the previous slide, it will be P even into P even. So P even can be said that we have total how many? How many even cards are there? 5. And the remaining card, because 3, 5, 9 was already taken out previously, so the total number of possible outcomes from which we can select these even cards are 1, 2, 3, 4, 5, 6, 7. So 7 cards. So 5 by 7. Now we have already taken one even card out. Let's say we have taken out 2 number. So so 2 number is taken out. So now again, when we from this, now how many cards are left? Now we're left with 6 cards. So the total number of possible outcomes are 6, because the remaining cards left are, because we have already taken one even number out. So now only 6 will left. And how many remaining even cards are left? So 1, 2, 3, 4. So 4. Now it can be written as 2 by 3. So this is going to be 10 divided by 21. So option B is your correct answer. And always remember one thing: whenever you are solving a question, and in the question it is not given that it is a dependent or an independent event, or or if in the question it is not given with or without replacement, so we will always consider it as without replacement. If it is not provided that the two cards are selected with or without replacement, so automatically you gonna select without replacement. Now let's move on to the next question. Question number 7. From the set -15, 10, -5, 0, 5, 10, 15, 20, if the numbers are chosen at random, what is the probability that it is a member of the solution of set mod x plus 2 is less than 8? So we have already read how to solve these mods and linear equations, in which we have read about inequality. So what we're going to do here is, if you will take this shift this mod on the other side, then this one would be x plus 2 would be greater than -8 and less than 8. So if you take mod on that side, then mod 8 would be plus -8. So x plus 2 would be greater than -8 and less than +8. We have read how to solve these mods and inequalities while studying linear equations. So from this, we can say that x is equal, if we take 2 on that side, so plus 2, so that would be -2. So 8 minus 2 would be 6. And if you take 2 on that side, so -8 minus 2, so -10 is there. So x greater than can be greater than -10 and less than 6. So -5 is greater than -10. We cannot take this one, because if it was given x is greater than and equal to 10, then we would have taken -10. If x is greater than or equal to -10, then we would have taken this number, but it is greater than, so we'll take -5, 0, and 5. So we'll have three favorable values of x in this limit. So only three numbers in the range. Only three numbers are in the range. That is -5, 0, and 5. So we have to find what is, so probability of x is, so favorable is, so we have 3 in this range, so favorable is 3 divided by total number of possible outcomes. So total possible outcomes sample set is 1, 2, 3, 4, 5, 6, 7, 8. 3 divided by 8. So option A is the correct answer. Now moving to the next question. In question number 1, a lot of 20 bulbs contains 4 defective bulbs. So total bulb lot has how many? 20 bulbs, in which defective bulbs are 4. So non-defective bulbs are, which are working properly, non-defecting bulbs are how many? Non-defecting bulbs are 20 minus 4, because in the lot of 20 bulbs, only 4 are defective, then remaining are working properly. So there will be 16. 20 minus 4, that is 16 non-defective bulbs. One bulb is drawn at a random from the lot. What is the probability that bulb is a defective? So P, probability of finding a defective bulb is, so total number of favorable outcome, that is defective bulb, that is 4, and divided by total number of possible outcomes, that is total bulb lot, that is 20 bulb. So that was going to be 1 by 5. So 1 by 5 can be written as 0.2. Part 2 of the question, it says that suppose the bulb drawn is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? So now we were having total 20 bulbs, in which 4 were defective and non-defective bulbs were 16. So now in second part, one non-defective bulb is taken out and it is not replaced. So it's a dependent event. So now how many bulbs are left? So one defective bulb is taken out. So non-defective bulb will be how many? 16 minus 1, that is non-defective bulb would be 16 minus 1, that is equal to 15. And defective bulb would be 4. Defective bulb would be 4 and total would be 15 plus 4, that is equal to 19. So now we have to find what is the probability that the bulb is not defective. So probability of non-defective bulb. So that is equal to favorable outcome. So after taking one defective bulb out, so we are left with 16 minus 1, that is 15 non-defective bulb divided by total number of bulbs left in the lot, that is 19. So 15 divided by 19. So that is going to be 0.789. So option B is your correct answer. Now let's move on to the next question. Question number 10, it says that a bag contains 3 blue marbles and 3 red marbles. What is the probability that you draw red marbles, two red marbles without replacement? So it is a dependent event. So as we can see, we have a bag here in which we can see we have 3 blue marbles and 3 red marbles. So total marbles in the bags are 3 plus 3, that is equal to 6. So now we have to, the question is given the probability that you draw 2 red marbles without replacement. So we have to draw out 2 red marbles. So probability of red marble and red marble. So P red and P red. So the first when we are taking out the first red marble, what is going to be the probability? The total number of marbles in the bags are, that is the total number of possible outcome, that is 6. And how many red marbles are there? We have 3 red marbles. So when first, let's take out this red marble outside. So now again we have to find the red marble because we are not replacing, because the question is given we have to draw two red marbles without replacing. So when we're going to find the next probability of drawing a red marble, so now we can see how many total marbles are there in the bag. That is 5. And how many red marbles are there in among those 5 left in the bag? That is 2. So 2, this will go one time. So 1 divided by 5. So this is your answer. There is one more way to solve these types of question by using combination formula. Combination formula. So the combination formula is NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. So this is your combination formula. Let me show you how we can use this combination formula to find this probability. So the probability of getting two red marbles, two red marbles, one after another without replacement. So as we know, favorable outcome divided by total number of possible outcome. So favorable outcome is we have total 3. Let me put it back in the bag. We have total 3 red marbles. So n would be the total number of uh, marbles that is asked in the question, whatever and we are drawing how many marbles out from those 3 red marbles? That is 2. In the question it is given we are drawing 2 red marbles and divided by total number of possible outcomes. So total number of marbles are 6. So 6 C, and we are drawing 2 marbles, 2 red marbles. So 2. So this is going to be a favorable outcome, and this is going to be a total number of possible outcome. Now we'll put it in. So 3C2 would be, so n would be 3 factorial. 3 factorial can be written as 3 into 2 into 1 divided by r factorial. So r is 2, so 2 factorial would be written as 2 into 1 multiplied by n minus r. So 3 minus 2 factorial, that is 1 factorial. So 1 factorial is 1. So from this we can say that the numerator is 3. Now 6C2, so this one would be 6 factorial. So 6 factorial can be written as 6 into 5 into 4 into 3 into 2 into 1. Or this whole thing can be also written as 4 factorial. If we divided by r, that would be 2 factorial. So 2 factorial would be 2 into 1 multiplied by n minus r factorial. That is 6 minus 2 factorial, that would be 4 factorial. So as we know, 4 into 3 into 2 into 1 is 4 factorial. So this and this would get cancelled. Now 3 times. So this is going to be 15. So 15. So 1 divided by, this will go 5 times. So your answer would be option C, 1 divided by 5. So you can use both of them. If you have read about permutation and combination, you can directly use combination formula. And if you haven't read it, then you can use this formula of multiplication rule. Now let's move on to the next question. This question says that in the box, there are B blue and G green marbles. So we don't know how many blue marbles are. It is said that it is blue. It is B marbles. It can be anything. B can be 1, 2, 3, 10, 100, 1000. It can be any integer. Similarly, for a green marble, it has G green marble. So G can be any number, 1, 2, any number. So if 2 marbles are selected by a person, what is the probability that both the marbles are blue? So we have to find P blue and blue, probability of blue. So first, this would be P blue into P blue. So from this we can say that the total number of marbles are B plus G, because B are blue marbles. We don't know exact number what it is, and G are green marbles. So the total number of marbles would be B plus G. Now what we're gonna do here is P blue. What we're gonna do here is now we will, whenever we are taking a because in the question it is said if two marbles are selected by a person, what is the probability that both are blue marbles? So now we will draw blue marbles out. So as we know, whenever we go, we have B number of blue marbles and total number of marbles are B plus G. Now let's say in the first part of the probability we have already taken one blue marble out. So let's take out one blue marble out. So now how many blue marbles are left? So now B minus one blue marbles are left. Green marbles are same. So now total is how much? How many? Total is total is G plus B minus one marble. So now when we find the probability of selecting the second blue marble, so we will select blue marble from this B minus one, because we have already taken one blue marble out from this B number of marbles. So now we are left with B minus one divided by total number of marbles left after drawing one blue marble out. That would be B plus G minus 1. So let me see that we have this option. So option D is your correct answer. Now let's move on to the next question. Yulan will use a bag of 30 solid colored marble for a game in which each player randomly draw a marble from the bag. The number of marbles of each color is shown in the table below. We have 10 blue marbles, 8 red marbles, 6 black, 4 white, and 2 green. So the question says that in the table below, Yulan will draw 2 marbles from the bag, one after another, without replacing. So without replacing means it is a dependent event. So what is the probability that Yulan will draw a black marble first? So first we are taking out a black marble out, and then a green marble later. So this is going to be probability of, first we are taking black and green. This is very important. If in a question and is given, then you will multiply those probability. And if in the next part we can see or is given, so we will, for and we will multiply the probability, and for or we will add those probability. So here and is given, so P probability of black marble and green marble. So this can be written as, because for and we will multiply black into P multiplied by green. So for and we will use multiplication. So what is the probability of finding a black marble? So total number of marbles are 30 and black marbles are 6. Now we have already drawn one marble out without replacing. So now how many are left? Total number of marbles are left 29 is left, because we have already drawn black marble first. So now we have to find the probability of getting a green marble. So how many green marbles are there? So 2 green marbles are there. This is going to be 5 times, so 2 divided by 29, 30 into 5 is 150, and minus 5, 145. So option for part 1, option B is your correct answer. Now let's come to the part 2 of this question. What is the probability Yulan will either draw a black or a green marble? Ultimately, they are drawing only one marble, either a black or a green marble. So from this, we can say that it is a independent event. Here without replacement. So this one was a dependent event. Here they have to draw either a black marble or a green marble. So it is an independent event. So we're gonna write it as P black or green. So it can be written as P black. And as we know, whenever or is given, we will add the probability. So P green. So what is the probability of blue marble? That is, sorry, black marble. Black marble. That is black. So that is 10 divided by 30 plus or is given. So we will add that. Then what is the probability of green marble? Here we are not drawing out two. Either we have to draw one green marble or a black marble. So the total number of marble will still remain 30. And we have to take out a green marble. So 2. So this is going to be 10 plus 2, that is 12 divided by 30. 6 times, 6, 2 times, and 5. So it is going to be 2 divided by 5. 8. Let me, sorry, black is 6. Black is 6. I have made a mistake here. The black is 6 plus 2. So this is going to be 8 divided by 30. 8 divided by 30. So it is going to be 4 divided by 15. This is going to be answer of part 2. Now let's move on to the next question. A jar of cookies contain 10 cookies of 3 types. So total we have 10 cookies, and in them there are 5 chocolate. So 5 chocolate. We have 3 butter. So 3 butter and 2 almond cookies. You reach into the jar and choose a cookie at random, and then without replacement, so it is a dependent event, choose another cookie. So we are choosing 2 cookies from the jar randomly. So what is the probability that both the cookies are of same type? So this is a question which was asked in ACT 2022. A lot of students were unable to solve this question. So the question says that what is the probability that both the cookies are you choose are of same type? So either we can choose chocolate and chocolate cookies, or we can choose butter and butter cookies, or almond and almond cookies. So we can have total 3 types of possible combination. So now let's find probability of all of them. So we can say that P chocolate and chocolate, or is given. So as we know, or can be substituted with plus sign because it is addition. Similarly, P, B and B. So B multiplied by B, or will be plus, then P almond and will be replaced with multiplication. Here also we will have and will be replaced with multiplication. So P, C, P, A. Now let's find the probability of finding 2 chocolate cookies one after another without replacement. So how many chocolate cookies we have? 5. And then we have total number of cookies, that is 10 into, now we have already taken one chocolate cookie out, so total number of cookies left is 9. And we have already taken one cookie out, one chocolate cookie out, so now we are left with 4 chocolate cookie. Similarly, uh, total number of cookies are 10, butter cookies are 3. After taking one butter cookie out, we are left with total 9 cookies, and we have already taken one butter cookie out, so now we'll have only 2 butter cookies left. Similarly, almond cookies, total number of cookies are 10, and we have 2 almond cookies. Now we have already taken one almond cookie out. Now we are left with total number of 9 cookies, and we have already taken one almond cookie out, so we are left with only one almond cookie. So we will solve it. 99 plus 6 divided by 90 plus 2 divided by 90. So this is going to be, so 5 into 4, sorry, 26. So 26 plus 2, 28 divided by 90. So this is going to be an answer. Option C is the correct answer. So this is a very important question. A lot of students who were unable to solve full marks because of this question was asked. Now let's move on to the next question. A bag contains 3 red balls and 4 blue balls. What is the probability that you select one red ball and one and is given and one blue ball at random from the bag? So here we don't know it, with or without replacement is not given. So by default, we will take without replacement. Whenever it is not given in the question that it is with or without replacement, by default, we will take it as without replacement. So the question says that the probability that you select one red ball and one blue ball at random. So there are two ways by which we can select one red ball and one blue ball. Either we can first select a red ball, then a blue ball, or we can first select a blue ball, then a red ball. So this is going to be our probability. So we can say that P, R, and red and blue, or probability of blue and red. We don't know if we are going to choose red or blue first, so we will take all the possibilities that is possible. So you can further say that P, R into P, B, or will be replaced with, because and will be replaced with multiplication sign and or will be replaced with addition. P, B into P, R. And we have to find it without replacement. So total balls are 7. 3 plus 4, 7. So first we have to find the probability of finding a red ball. So total number of balls are 7. And we have 3 red balls. We have taken one red ball outside without replacing it. We have to find the probability of blue ball. So we have already taken one red ball outside. So total number of balls left are 6. And we have to find blue balls. So we have 4 blue balls. So this is now in this, first we have to find the probability of finding the blue balls. So total balls are 7 and blue balls are 4. After taking one blue ball out, we are left with six balls. And from those 6 balls, we have to find the probability of the red balls. So red balls are 3. So we can 7 into 6, 42, and 12 and plus 12. So 12 plus 12. So 24 divided by 42. Can we further factorize it? Let me see, 4 times, 7 times. So 4 divided by 7. So option B is your correct answer. So this is one way to solve it. As we can see that we have two possible combinations here. And that first, either we can take a red ball, then we can take draw a blue ball, or we can first draw a blue ball, then we can draw a red ball. So we have total 2 combinations. So there's one more method to solve this question is, so total possible combinations are total number of possible combination. So we have 2 types of ball here. So if you have red permutation and combination, so if you have 2 types of balls here, so we will have 2 factorial. The total number of possible combination is 2 factorial. So it can be also written as 2 into 1. So that is equal to 2. So what we're going to do here is we can find probability of one of the possible combination, that is P, probability of R and B, and we will multiply it by total number of possible combination, that is 2. So if probability of R and B, from this we can say that it is 12 divided by, because we have solved it here. So this is equal to 12 by 42 into 2, because total number of possible outcomes are either we can take red ball first and blue ball later, or blue ball first and red ball later. So we have total number possible outcome, that is 2 factorial, which is equal to 2. So we will find the probability and we'll multiply it by 2. And as we can see, both the values are same, 12 by 42, and this is also 12 by 42. So this is going to be 24 by 42 into 2. So sorry, this is 12 by 42. So 4 and 7. So option B is the correct answer. So either you can solve it like this, or you just have to find the probability of a red and blue ball and multiply it by total number of possible outcome. That is 2, because either we can have red and blue or blue and red. So these are two methods. This is slightly lengthy and this is slightly smaller. It needs a little bit less calculation. Now let's move on to the last question. This question was this question was asked in a I think it was asked in SAT 2022. SAT 2022. A lot of students made a mistake here. They just solved this part. They forgot about the number of possible combination. So a lot of students made this mistake in 2022. And this is a question from ACT 2021. This is an ACT 2021 question. Most of my students who were unable to score 8 out of full marks in 800 out of 800 marks because of this question. So of the 16 cars on a rental car shop, 6 are Ferrari, so 6 are Ferrari, 7 are BMW, and 3 are Mercedes. And total is 16 cars. Robert will rent 3 of these cars chosen at random for business associate. What is the probability Robert will rent one car from each brand? So we can say that either probability of finding a Ferrari and BMW and Mercedes. So this is, so let's find out. So P, probability of Ferrari, probability of BMW, and probability of Mercedes. So as we can see that we have total number of cars as 16. And how many Ferraris do we have? 6. Now after taking one Ferrari out, we are left with, because nothing is given here, so we will, by default, we will take it as without replacement. Nothing is given in the question that with or without replacement, so by default we'll take it without replacement. So it is a dependent event. So when one Ferrari is taken out, then we are left with total number of cars is 15, and we have to find the probability of a BMW. So BMW has 7. Now after taking a Ferrari and BMW out, we are left with 14 cars. Total cars are 14, and we have 3 Mercedes. So let me solve it. So this is 3 divided by 80. So when my students gave the attempted this question, they were saying that we didn't find the answer in the option. As we can see, the answer that we have found here is not in the option. So they made one mistake here, that they have they forgot about the total number of possible combination of cars. So we have taken only one combination, that is first you will buy a Ferrari, then a BMW, then a Mercedes. We can also do this Ferrari, then Mercedes, then BMW, or BMW, Ferrari, Mercedes, or BMW, Mercedes and Ferrari, Mercedes, Ferrari, BMW, and Mercedes, BMW, and Ferrari. So to total how many number of possible combinations can we have? That is 1, 2, 3, 4, 5, 6. And in the previous questions, we have found the total number of possible combination is total number of variables, that is red and blue ball. So we'll have to find the factorial. So two types of balls are there. So 2 factorial will be there. Here, total number of possible combination. As we in previous question, we have 2 types of balls, red and blue ball. Here we have 3 types of car, Ferrari, Mercedes, and BMW. So this will be 3 factorial. So 3 factorial is 3 into 2 into 1. So 6 possible combinations are. So whenever we have to find the answer, we will just multiply it by 6. So the probability and types of possible combination, that is 6. So When we solve it, it is going to be 18 divided by 80. So 9 and divided by 42 times. So this is going to be 9 divided by 40. Option C is your correct answer. So this was the last question. Now, these are few practice questions on the topic which I have taught you recently in the video. Do solve these questions to test yourself and write down the answer in the comment section. Students who will answer all the questions correctly, I will pin their comment in the comment section. If you like the way I teach and want to buy a comprehensive course for SAT exam starting at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description below. One more thing, do not forget to like, share, and subscribe to this channel so you can get updates of upcoming free videos that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.